Hello, my name is George C. Bradley, and today's presentation will be on how to run a factor analysis using SPSS, and we're talking about exploratory factor analysis. Factor analysis is a technique used to identify factors that statistically explain the variation and the covariation among measures. Generally, the number of factors is considerably smaller than the number of measures, and consequently the factors succinctly represent a set of measures. From this perspective, factor analysis can be viewed as a dimension reduction technique, since it reduces a large number of overlapping measured variables to a much smaller set of factors. Our database today, our data set today, is the National Married Twin Studies. Each case is an individual documentation, and you can see right here the reference if you want to find out more information. The title of the the name of the data set is nwtwins.sav, and it's free and it's online. Our variables here, we have several, and we have our paired numbers, the ID of the twins, the sex. We have the zygosity variable, and we have mother's educational level, father's educational level, and we have family income. We have our national merit subtest: English, mathematics, social studies, national natural science, social science, and vocabulary. Now we have our stages of our exploratory factor analysis. We have extraction, rotation, and reliability, and the primary objective of the first stage is to make an initial decision about the number of factors underlying in a set of measured variables. The goal of the second stage is twofold: statistically manipulate to rotate factors, the results to make a factor more interpretable, and B, to make final decisions about the number of underlying factors and also give them a name and make interpretations, and 3, to check the reliability coefficient of the factors that were extracted. Now let's conduct an exploratory factor analysis using this data set, and we will start by going to Analyze, Dimension Reduction Factor. We can do a Control A here and move all of them to our variables box. Let's take out the top 3 and move it back over. Now we'll click here. Univariate description. We have our coefficients, significant levels, determinant, and KMO and Bartlett test of sphericity. Let's click on all of those. Let's go to our extraction, stage 1. Principal component is the method. Spree plot. Continue. We're hit OK. Now we're looking at stage 1. We have our descriptive information. You can look at the mean standard deviation. Our numbers, we have 1,536. We can look at our correlation matrix here. Correlation matrix, all of them seem to be pretty strong. All are significant, But let's look at our KMO Bartlett test, and we can look at the first KMO that is above 0.5. If it's above 0.5, that means that we have a real strong sample size. There, we can look at the significant level, and if it's below 0.05, that means we're okay there. We can move down here, and we can look at our total variance explained. We look at our eigenvalues, what we want to see any that were over 1, and we have 2, and those 2, we have the first one that accounts for 48, and the second one that accounts for about 20% of the variance. If you combine them, that is around 69, and you can look at our spree plot there, and it can show you the same thing that you have there in the total variance explained. We can look at our components matrix, and we could see some valuable information there, but we're going to move here to the rotation. And we'll go back here to dimension reduction factors. Right here, we're okay. We can go to extraction again. Now, I'm going to move to maximum likelihood. We could use others, but let's click over to fixed number of factors. And with our extraction, our fixed number of factors, eigenvalues above 1 was 2. We will hit continue. Go to rotation. As rotation, we talk about this a little bit. If we have direct oblumine, direct oblumine means that the correlation is strongly correlated. If we have Varimax, then it's minimum correlation there. We're going to start it off and assume that we have, by looking at the correlation coefficient, all of them seem to be strong. We're going to start there first. Now, if it doesn't meet the requirement, we might have to go back to Varimax. But let's take a look at that. Hit here scores. We want to look at these scores because we want to set up 2 other variables that loaded over the eigenvalue of 1. And so we have that set up. And right here, on coefficient display format, we'll suppress the small ones. And normally the standard is 0.3, but I'm going to make it a little more strenuous and go to 0.4. Okay, I think I have everything set like we need it. We'll go down and let's check to see if we need to go back to Varimax. Okay, we're okay here. The factor correlation matrix, if these 2 right here, that is at 0.37, if they were below 0.32, then I would probably have to move to Varimax. As we can see, our structured matrix, pattern matrix, all of them are basically saying the same thing. In the factor, you have a split here, but you would go with the top one. And you can see right here with our rotation that they loaded nicely with the family information, education, and income, and with the national merit test in the different subject areas. That's factor 1, and the one with the family is factor 2. Okay, now let's go to our final stage and look at reliability. We'll go to scale, reliability, and we'll go to factor 1 first. Factor 1. Okay, everything's there, only factor 1. This is important. Make sure when you have your doing your reliability coefficient that you always use this descriptive statistic scale if item deleted. That's important. Okay, we'll do that. Click here. Okay, you can see right there that the Cronbach alpha is 0.88, which is very strong. That group loaded nicely. If we were to delete mathematics, we would have 0.78. So you can see what we have here is already the strongest. Let's look at our second factor. Second factor, scale, reliability. I'll go over here, Control A, take that and put it back in that box. Mother's education, the family information across. That looks good. Okay, now we have 0.74, which is good. Nicely loaded. We can go over here to our items, total statistics. We don't have to delete anything because the one that we have, is the strongest, and that is excellent. Let's take one look at our data set. We have our first factor there that dealt with the national merit twin information. Now we have that grouped into one variable, and the information pertaining to the family information is grouped in one information, so you can use that in an analysis, which you have 5 of these variables out into one, and then you had 3 into 1 there. Thank you. If you have any questions, please email me at georgecbradley59@gmail.com. Thank you.